So in this video, we'll be discussing paper 3 for October-November 2024, paper 3. Right, so let's start with question number 1. We are given the complex number that satisfy all these equation and inequality. So we are having modulus z equals to 2. We are having the argument z is between 0 until pi over 4. So part A, on the Argand diagram below, sketch the locus of the point representing z. Right, so let's have a look for our locus here first. Okay, so first of all, we are having modulus z equals to 2, right? When we want to write it into the locus form, it should be modulus z minus a complex number equals to 2. So for this one, there's nothing here in the equation. So the complex number you should write as 0 plus 0i. So what does it mean here? It basically means that the distance from z to 0, 0 is always equals to 2. Modulus means distance, right? And if you try to plot all the locus, right, all the point of z, by right, you will get the locus, which is a circle. A circle with the center 0, 0 and with the radius 2. So already know that this is a circle, yeah? Then let's continue. For the second inequality, they are saying that the argument z is between 0 until 4. So again, if I want to rephrase it into the pattern where I'm having argument, then z minus a complex number is smaller equals to pi over 4. So what is the complex number here? It is also 0 plus 0i. So taking 0 and 0 as a reference point, we are going to sketch the argument for the z for pi over 4. Okay, then after that, you should shade the area because this is an inequality. So when you want to draw it out, later you have to shade the area. Then this one is equal sign. Therefore, it should be a line. All right. So let us start with this one first. Okay, so we already know that the center is 0, 0. So we can maybe label this as a 2, this one as maybe 2, then negative 2, and also negative 2 here. Okay, then we try to plot them and draw a circle. So we try to sketch it as circle as possible, right? Okay, all right. So this is my first locus here, and after that, I want to sketch also this one z from 0, 0. I let it equals to pi over 4. Pi over 4 first. That means on the right hand side of 0, 0, I need to draw a line and measure the angle to be pi over 4. So pi over 4 means that you pass through the coordinate 2 and 2. All right, so from center 0, 0, from the 0, 0, you need to draw a line that pass through the 2, 2 or 1, 1 or 3, 3 or whatsoever. Okay, and then this is basically pi over 4. The angle here. Okay, this angle is pi over 4. All right, then now, if you want to make sure that the locus fulfill both equation and inequality here, so let's have a look for this one first. It is equals to 2. That means any point along, okay, or on the circle, it will be fulfill this equation. And then they say z must be from 0 until pi over 4. So 0 until pi over 4 means that it should be below this area. Okay, so try to imagine what is the overlapping part for this shaded area and also the circle. So the overlapping part basically is this one. This is the overlapping part. Okay, therefore, the locus that fulfill these two conditions here basically is the black color line. Okay, so this black color line is our locus z. Okay, so we are not because you have to see the overlapping of the two shaded area. So one of them is below the line, another one is on the circle, right? So the overlapping part, eventually there's only one curve here, the small curve here, and this is my locus z. Okay, then let's continue further for part number B. So for part B, they also say that on the same diagram, sketch the locus of the point representing z squared. Okay, I also want to sketch the locus for the z square. So let us set up a little bit for the z square first. Okay, so for part B, previously we did learn a formula where the modulus of z square basically can be get by using modulus z multiplied with modulus z. So just now you know that modulus z is a 2, right? So you're having 2 multiplied with 2. And you are having a 4. Okay, so what does it mean here? So basically this one means that you're having modulus z square minus 0 plus 0i equals to 4. So to sketch the z square, you are having a circle with the center 0, 0 and with the radius 4. Okay, then next one, how to get the locus for z square in the second inequality here? So again, the same thing happened. Last time when we talked about the argument of z square, to find the argument, basically we can take argument of z plus argument of z. Okay, so let's have a look for the inequality here. I'm having 0. If I want to get the argument of z square, right? So that means I'm having argument z plus argument z here, which is 0 plus 0 here. So what's the value for 0 plus 0? Of course, it is a 0. Okay, then what happened to the pi over 4? This one. Okay, so originally argument z is pi over 4, but if you're having argument z squared, that means you have to take argument z plus argument z, where you should get pi over 4 plus pi over 4. So pi over 4 and pi over 4 by right, you should get a 90 degree, which is pi over 2. Okay, and let's set up this question now. So first locus that I need to draw is this one, where z square from 0 and 0 equals to 4. That means I will be having a circle with the center 0, 0 again. And then the radius is a 4. So maybe the radius 4 will be somewhere higher here. Okay, so this is 4. Then this is negative 4. And this is negative 4. Okay, so try to draw the circle. Okay, so my circle might not be so nice, yeah, so please bear with it. Then for you, if in the exam, you try to draw it as nice as possible. Okay, yeah, so this is the first one where you're having modulus z squared equals to 4. How about the next part? So for the next part, you have to draw 0 is still a horizontal line, right? And then you have to draw from 0, 0, okay? The angle measure is pi over 2. So if you try to measure from 0, 0, go up, then your z should be this vertical line. Okay, this vertical line. And then they say the area that I want is between 0 until pi over 2. So for this inequality, the area that we want to cover is basically the first quadrant. It is between 0 and also until pi over 2. And your pi over 2 is the green color line there, right? So basically it's this whole area here. And let's look for the overlapping of these two equation and also the inequality. So z squared equals to 4. Modulus equals to 4. That means it is on the circle. Any point on the circle. And then for this inequality, it is the area shaded in yellow color here. So where's the overlapping part of these two equation and inequality? So you can see clearly that by right, your locus of z squared should be this one. Okay, it is on the circle and also within the shaded area in the yellow color here. Alright, yeah, so I should label it clearly where this one should be actually the z squared. Okay, so I hope that you understand how we get the z and also the modulus of z squared with the argument, and also know how to sketch the diagram correctly. So by right, you should emphasize in your solution where your z is this black color one, and also your z squared should be this black color curve as well, right? Okay, so let's continue. There's no more, right? Part A and part B only, yeah. So this is how we answer question number 1. So question number 2, we are given a function. They want us to show that if there's a sequence of values are given by the iterative formula like this, can converge, right? Then it converges to the root of the equation of fx equals to 0. So we have to just try to rearrange this iterative formula to get fx equals to 0. So we just need to rearrange them, right? So I'm having x equals to square root 4 over 5 minus 2x. So first step, we try to square both sides to get rid of the square root. Then after that, I multiply the denominator up to the other side. Okay, so I'm having 5x squared minus 2x cubed equals to 4. Then I further rearrange my equation here. I'm having 2x cubed minus 5x squared plus 4, and it should be equals to 0. So from here you can see clearly that basically we already get fx equals to 0, right? Yeah, so this is how we prove the iterative formula to get back the original equation, but we are letting the function fx equals to 0. Okay, then let's have a look for next part. So for the next part, they say that the equation has a root close to 1.2, and they want us to use the iterative formula from part A and the initial value of 1.2, determine the root correct to 2 decimal places, then give each iteration to 4 decimal places. Okay, so we are having x1, which is equals to 1.2. So for this case, the initial value is given. Okay, then of course we have to key in the iterative formula. So to key in the iterative formula, we kindly key in the right hand side only. So you're having a calculator. Then by right, you should be having square root with a fraction inside. Then the number on top is a 4. Then divided by 5 minus 2x. So to key in the x, it should be alpha close bracket. Okay, so let's have a look for our solution here. Okay, so first, our initial value is 1.2, right? So first of all, let's click on calculate. And they're asking you what is the value of x that you want to key in. So let us input the 1.2. Then press equal sign. And then you're having this fraction here. Since we need the iteration in decimal number, so we are changing it into decimal number here. So please write it out in 4 decimal places. So the answer should be 1.2403. So our value here will be 1.2403. Okay, then how to get the next value for x3? So let's continue further. Alright, so we press calculate again. Then key in the value of x2, which is 1.2403. Then press equal sign. Then I'm having 1.2600. So I put 1.2600. So we shall continue this one until we get the 2 decimal places answer repeated. For me, I will want to make sure that the answer is the correct answer. So I will usually repeat until, for the 2 decimal places, answer repeat until 3 times. Then only I will stop. Okay. To me, I think better is 3 times. If let's say you stop at, you repeat only for 2 times, right? There are some example actually we did see that before that repeated 2 times, after that the answer changed again. So I think better we still set it as 3 times, alright? Okay, then next value is x equals to 4. Okay, so press calculate again. Then to get x equals to 4, I have to put the x3 value, which is 1.2600. 1.2600. Then press equal sign. Then you get another fraction. So we change it, become decimal number. So we are having 1.2700. So 1.2700. Okay, so let's continue further for x5. I think it is quite obvious, yeah. The answer here is not repeated yet. Okay, so let's have a look for x5. So what's the value for x5 here? Then again, we key in 2700. Press calculate. Key in the value 1.2700. Then press equal sign. Okay, so we're having 1.2752. 1.2752. Okay, haven't repeated yet, the 2 decimal answer. So let us have a look for x6. Press calculate. 1.2752 equal sign. Then this one is 1.2779. So 1.2779. If I double check the answer here, right, this answer is 1.28 correct to 2 decimal places. This one is also 1.28 correct to 2 decimal places. So by right, if you want to stop here, can, but for me, usually I want it to be more secure, right? So I will just continue for one more iteration. So I want to get x7 here. So to get the x7 here, then repeat the process again, calculate 1.2779. Equal sign. So we're having 1.2793. So 1.2793. Then if I double check 2 decimal places answer, it is 1.28. So I can actually conclude now that the root for this function should be 1.28. Correct to 2 decimal places, right? According to what the question request for. Okay, so this is how we solve question. So let's discuss question number 3. They are talking about the number of bacteria in the population P. At the time T hours is modeled by the equation like this. Okay, so A and K are constants. Then they are plotting the graph of ln P against the T. Ln P against the T, shown in the diagram, has gradient 1 over 20. This is a very important information. And intersect at the vertices, vertical axis at 0, 3. So they want us to state the value of K and also find the value of A correct to do significant figure. So if let's say we are given a linear equation, right? This is a linear line, a straight line. So we should try to convert our curve into a linear equation as well, so that we can compare them directly, then to get the value of constant from the linear equation. So we are having the original equation, which is P equals to A e power kt. Okay, so first step, let's take ln both sides. Okay, after that, we expand all the terms by using the ln property. So I'm having kt ln e. But ln e is a 1, therefore I will just ignore it as a 1. I didn't write it out. So this is my equation that I get when I try to take ln both sides. And now I want to compare it with linear equation. The linear equation formula is y equals to mx plus c. Okay, so you can actually try to compare them. Y means y-axis. You can see that it's actually ln p. X means x-axis, because basically you can see that it's a t. So if I compare the remaining part here, m is the gradient, it is actually equals to the value of the k. So I think from here we can state the value of k very easily, because we have been given the gradient, which is 1 over 20, right? So what we have here is you are having k equals to 1 over 20. Alright, then after that, how about the A? So the A, we have to compare with the y-intercept. C is the y-intercept, right? And from here, if you try to figure out ln A is equals to the y-intercept. What's the value for y-intercept here? It is actually a 3. So let it equals to 3. So A is equals to e power 3. And then we try to get the answer into 2 significant figure. When you press calculator, by right, you will get 20. Okay, so this is how we actually get the value for A and also the K. Okay, so let's have a look for next part. Okay, so for next part, they want us to find the time taken for P to double. Give your answer correct to the nearest hour. Alright, so let's have a look for our original equation first. We are having P equals to A e power kt. Okay, so I will let P equals to A, the value that we get just now is 20, e power kt, so it should be t over 20, right? K is 1 over 20. So this is my original equation. Okay, alright. So first of all, when they said we want the value of P to double, right? I want to know what is the time. So maybe we actually need to know what is the certain value for P at a certain time first. After that, only you can let the P equals to double of the value, then only we can find the time that needs for P to grow or double. Alright. Okay, so what I do here is basically I try to let T equals to 0. I want to know at T equals to 0, like, what is the value of the P? So the P is equals to 20, right? Okay, substitute T equals to 0 inside the equation. I get the value of P, which is equals to 20. So that means now, if I want to make the P double, so double means I want to let the P equals to 40. And I want to know what happened to the time that I get. So P equals to 40 equals to 20 e power t over 20. So simplify the equation. Then to find out the value for t, you can take ln both sides. And eventually you get t over 20 equals to ln 20. Then again, just try to move all the number to one side and simplify them. Oh, sorry, I make a careless mistake here, right? This one should be a 2, right? Okay. Yeah, this one is also a 2. Okay, then t is equals to 20 ln 2. And since they want us to put our answer into the nearest hour, so we actually have to try to get the decimal number for the t. Okay, so by right, the t is equals to 13.86 something. Then the nearest hour will be 14. So that means the bacteria need 14 hours to double the value of the p. Now we solve question. So we are now at question number 4. They want us to find the complex number z that's satisfying the equation. Okay, this is the equation that we have. And you need to take note that z is a complex number, yeah? Okay, so give your answer in the form of x plus iy, where x and y are real. So let's find out the z. So you know that z is actually x plus yi. There are two ways for you to solve it. The first one is you either get rid of the denominator first for the equation. Okay, equals to 2 minus 9i divided by 5. So if I want to get rid of the denominator, what I do is I cross product the denominator to the other side. Okay, this one also I multiply it to the other side. Okay, so by right I should be having 5, then z minus 3i, okay, equals to 2 minus 9i, then z plus 3i. Okay, so this is the first step that I carried out. So I want to actually make the denominator disappear. So that's why I cross multiply it. Okay, so there's one common mistake that a student might do here is when they look at this one, z minus 3i and also z plus 3i, I think some of them tends to rationalize it by using z minus 3i and also z minus 3i. Okay, so if you are trying to carry out this particular step, I didn't try out before, but in my opinion, I don't think that it is correct. So if you have a try and then you successfully get the answer later, then maybe you can let me know in the comment part later, right? Okay, so in my opinion, this is not the correct method, and I think some of the students might do it in this way, but to me, it is not really correct. It is not correct. Okay. So why is it not correct? It is because of z is actually a complex number x plus yi, right? So your real part for the denominator basically is x plus y plus 3i. Okay, so when you want to rationalize it, so you should actually multiply it with x minus y plus 3i. Okay, so when you have z minus 3i, it actually means that x plus yi minus 3i. So if you double check, by right, you should actually rationalize it by using this one. But what you write here is actually this one. Therefore, I don't think that it is a correct way for you to rationalize it. Okay, but I want to emphasize again, I never complete and continue by using this method. So if you did this method and you successfully get the answer, kindly let me know, okay, in the comment part. Alright, so let's continue further. So we come back to our solution here. Okay, so I'm having 5. So I want to explain everything. I'm having 5z minus 15i, 2z plus 6i minus 9zi. Then I'm having 27 negative with I squared, which will become positive 27. Okay, then now what I want to do now is I try to group all the z at one side because my aim is to find out the complex number z. So to find out the complex number z, what I do is I try to group all of them together, all the z. So I'm having 5z. Bring the 2z over, become 5 minus 3, which is 5 minus 2, which is 3z. Negative 9zi, I bring it over, become positive 9zi. Then equals to, simplify all the other term, I'm having 27. 15, bring it over, become positive, right? So I'm having positive 15 plus 6, which is 21i. Okay, so to find the z, I can factorize them out. Okay, so next step, excuse me, what I have here is this one. So z basically equals to this complex number, but of course, in this stage, I need to rationalize it. Okay, yeah, so sorry, I think I made the careless mistake here. This one should be 21i. This one also 21i. Then if you realize this fraction, you can still simplify. Okay, because you can take out the 3 on top. And also the 3 at the bottom. So you simplify the 3. Okay, then after that, I'm having 9 plus 7i divided by 1 plus 3i. Basically, this is the z already. This is the z. But we usually can't keep it in the rational, in this fraction with complex number at denominator, right? So what we're going to do is, we have to rationalize it at this case. So that I will get the z in the proper form of x plus y. Okay, so I rationalize it. So I have to multiply 1 minus 3i top and bottom. Then I try to simplify my expression here and get the z. Okay, for denominator it is 1. Negative 9 with i squared, so it will become positive 9. For the term on top, you try to expand it like a bracket. So 9 multiplied with 1, you get a 9. 9 minus 3i multiply, you have 27i. Then plus 7i. Then negative 21i squared. So it will be positive 21. Okay, so you're having 30 minus 20i divided by 10. So please further simplify your z. You should be getting 3 minus 2i. Okay, so this is how I solve this question. And then I believe that there's another method where you can also try to use it. Some students, they directly substitute x plus yi in the z. And then after that, they try to compare the real part with real part, imaginary part. So I believe that that method also can lead you to the correct answer. Okay, so this is how we answer question number 5. Alright, so we are now at question number 5. They want us to show that this particular part equals to the expression on the left, on the right. Okay, so we shall start with this left hand side. Okay, then left hand side, I'm having cos power 4 theta minus sine power 4 theta minus 4 sine square cos square. Okay, I want to reduce my equation because my equation now currently all are having very high power. I want to reduce it become a lower power. And all of them are having single angle, all the theta. Then after that, our right hand side is having double angle. So we might need to apply the double angle formula backward. So before we start, maybe we can have a look for this one first. How can we simplify cos power 4 minus sine power 4? Our double angle, right? Basically, we are having a lot of double angle with the power 2, 1. As an example, if let's say you can remember, right? Okay, the double angle formula that we have basically is like this. So we might have cos 2 theta equals to cos square theta minus sine square theta. Or I can have 2 cos square theta minus 1. Or I can have 1 minus 2 sine square theta. Okay, so all this you can see that in double angle formula, we are having all the square. Mostly they are square. So that means for the power 4, right, we actually have to reduce the power first. So let us have a look. How can we reduce this power here? Cos power 4 minus sine power 4. Basically, we can change it become cos square minus sine square. Multiply with cos square plus sine square. Okay, so by changing this to this part, right, I'm using one basic factor formula before, where x squared minus y squared can be written as x minus y and also x plus y. So this is how we reduce the power, yeah, for cos power 4 and also sine power 4. Okay, then after that, minus. Okay, for this part, we know that I can rephrase it become 2 sine theta cos theta then square. Okay, so why I rephrase it in this way? It is because of I have another formula, identity, where sine 2 theta can be written as 2 sine theta cos theta. So if I want to apply it in a reverse way, right, so I rephrase it become 2 sine theta cos theta first. Alright, okay, so next step. Cos square theta plus sine square theta will give you a value of 1. So I'm having cos square theta minus sine square theta left. So cos square theta minus sine square theta is basically equals to cos 2 theta. So I'm having cos 2 theta here. Minus, for this one, 2 sine theta cos theta, I will be having sine 2 theta. Applying this particular formula, right, in the backward. So I'm having still a square outside. So I have cos square minus sine square. And according to our equation here, you can see that there's no sine square. Okay, there's no sine square. So what happened to the sine square here? So I have to think away, change the sine square become cos square. So how to change sine square become cos square? So we recall again, we have one identity in AS inverse where sine square plus cos square is equals to 1, right? So we are going to apply this. Therefore, for our sine square 2 theta, I can write it become 1 minus cos square 2 theta. So you can see that you are bringing the cos square over, become 1 minus cos square. So this is what you get. Okay, so try to rephrase everything one more time. So this is how you get the expression that they want you to prove in on the right hand side. Yeah. Alright, this is the part A for proving. So to make the proving part more smooth, right? Okay. Actually, I will strongly suggest you to memorize the identity for the double angle, because to me, I think it is very useful, not only in the proving part, and it is quite useful also if you are using it in the integration part as well. So usually for me, I will strongly suggest that if you can, you try to memorize the double angle formula, especially for cos and also the sine. Okay, we are using it quite frequently. So if you have all this formula in your mind, at least you know what is the formula that can be used, or you can refer, or what kind of formula you can use so that they lead to the final answer that you want, right? Okay, so let's continue to part B. Okay, so for part B, they want you to solve the equation for alpha between 0 to 180. Alright, so you can see that this equation basically is the same. Okay, this equation basically is the same like what they want us to prove earlier, because if you try to remove it, if you try to rephrase it, so you will have this equation, cos power 4 alpha minus sine power 4 alpha, then minus 4 sine square alpha cos square alpha equal to 0, right? And this equation is basically what they want us to show on the previous part, the left-hand side. The left-hand side expression is this one. Okay, so you can directly substitute the right-hand side expression into this part. So you're having cos square. They change the alpha become, theta become alpha. So you write cos square 2 alpha, then plus cos 2 alpha minus 1 equals to 0. And if you can see, this is basically a quadratic form equation. So please solve the quadratic form equation. I cannot factorize this equation. If you try, then you'll see that you're not able to factorize the equation. Therefore, you have to solve it by using the quadratic formula. So quadratic formula is negative b plus minus b squared minus 4 ac, then divided by 2a. Alright, then simplify it. Okay, then after that, you try to solve cos 2a, 2 alpha. Alright, so the first value will be negative 1 plus sub 5 divided by 2. Another value will be from the equation cos 2 alpha equals to negative 1 minus sub 5 divided by 2. Okay, then if you try to press calculator, yeah, this value is already less than negative 1. So when you are having any value less than negative 1 and cos function equals to something less than negative 1, there's no solution because the range for cos is between negative 1 until positive 1, right? So anything below the negative 1, there will be no solution for the trigo equation. So you can directly ignore it. And then for this part, of course, you have to find out the alpha first. Okay, so I write it out. I write out the basic angle first. So before you can find the alpha, you have to write out the basic angle. So the basic angle is you press cos inverse, then this particular value. By right, you should be getting 51.8. Okay, then we are going through the quadrant so that we see now what is the quadrant that you want to consider the answer. Okay, in the question, they want us to have our alpha from 0 until 180. But now we are looking for the value for 2 alpha, right? So to look for the value of 2 alpha, you should be looking for 0 until 360. Okay, then you go through the quadrant, right? So let's have a look for all the quadrant here, all sine, tangent, cos. Okay, so this is the formula. Okay, so for the first quadrant, we assume that all the data here is the basic angle, yeah? So we already get our basic angle here, right? Okay, we are looking for cos positive value. Okay, cos positive value. So where is the quadrant that I'm having cos positive? So for the first quadrant, is cos positive? Yes. So I want to accept the answer from this part where it should be a basic angle. So where's our basic angle here is 51.8. Then second quadrant, cos is negative. Therefore, I don't want the answer from this part. Third quadrant, cos is also negative. I also don't want the answer from here. Then in the fourth quadrant, cos is positive. So I want the answer from this part. How I get it? The answer is 360 minus the basic angle. So when you're having 360 minus the basic angle, you have 308.2. And after that, you try to get the alpha. So by right, the alpha should be 25.9 and also 154.1. Okay, so if you're not able to get the answer that I show here, right, as the final answer here, maybe when you go back to the basic angle, when you press for the calculator, maybe you have to use the long value for the calculation for alpha. That means you keep the long value, don't keep it as 51.8. Alright, yeah, so this is how we solve question number 5. Alright, so question number 6. We are given the line L and line M with the vector equation like this. So line L and M intersect at point P. So state the coordinate of point P. Alright, so like what we all know, right? Basically, vector equation means that the structure is R equals to A plus TP, right? Okay, so where A is the passing point of the line, P is the direction of the line. When you look at this particular equation, right, you are having line L, but the passing point is 2, 1, and negative 3. Then the direction is negative 1, 0, and 2. For the line M, the passing point is 2, 1, and negative 3. And then the direction is this one. Okay, so we try to observe the passing point for line L and also line M. So you can see that their passing point is the same, which is 2, 1, and negative 3. Which means that line L, okay, is having line point 2, 1, negative 3 as a passing point. Then line M is also having 2, 1, and negative 3 as a passing point. So you can see that basically this is the intersection point between the line L and also line M. So that's the reason why they ask us to state the coordinate of P. Okay, so to state the coordinate of P, highlight the keyword coordinate. So I want to emphasize here, when they're talking about coordinate, please write out in the coordinate form, which is a Cartesian form in X, Y, and Z. So don't write it out in the position vector form, okay, or any vector form. All right. Okay. So what is the coordinate of P, so very obvious, it should be 2 and then 1 and also negative 3. So this is what you have for part A. So no need to show any steps because it is basically only the mark for answer. State the coordinate of P. So let's continue to part B. Right, so for part B, they want to find the exact value, have the keyword exact value of the cosine of acute angle, cosine of the acute angle between line L and also line M. Okay, so this one is like we want to find the angle between two vectors. When you want to find the angle between two vectors, we need the direction. So let's have a look for our line again. What is the direction for the line L? So the direction for the line L is basically -1, 0, and 2. And what's the direction for the line M? So it is actually 2, -1, and also the 5. Okay, so please try to find out the angle for these two vector, right? Okay, so I copy it down here. So let's name the direction first. Okay, so maybe we name the first direction as direction of L, right? Is -1, 0, and also 2. Then multiply with, dot product with the direction 2, -1, and also the 5. Okay, then what is the formula here? So the formula here is the modulus of the first direction, which is -1 square plus 0 square plus 2 square. Then you are having also the modulus for second direction, 2 square plus -1 square plus 5 square. Then cos theta. Okay, and just in case, if you already forget, right, what is the general formula for this one? I just have to recall a little bit. In AS syllabus, we did learn about the angle between two vectors. So the angle between two vectors is you need to use the dot product or scalar product. Okay, where you take the vector P, dot product with the vector Q, and then equals to modulus of the vector P, modulus of the vector Q, and then cos theta. So this is what we are doing now. Alright, because we are interested for the angle between two lines. So we are using the direction of the two lines and try to apply in this formula. Okay, right. So for the dot product, you multiply x with x, you have -2. Then plus, multiply y with the y, you get a 0. Then plus, multiply z with z, 5 times 2, you get a 10. Equals to, try to simplify the value on the right hand side. 2 square plus 1 square is a 5. 2 square plus 1 square plus 5 square should be 30. Then cos theta. Okay, so let's revise the question one more time. If you have looked for the question, they said they want you to find the value of cosine of acute angle. Cosine of acute angle. And they want to have cosine. So that means you just keep the cos theta together. You bring all the number to the other side. Okay, then after that, how to make sure that it is the cosine of acute angle. So if you double check your value here, it is a positive value. That means definitely it will be the acute angle already. Alright, so if you get a negative, to get the acute angle, you have to make it become positive. That's it. Just directly cancel off or just ignore the negative sign. Right. Okay, so eventually this is what I have. So cos theta equals to, if you want, you can keep it into 8 over square root 150. Okay. Or if you want, you can further rationalize it. So to rationalize it, what am I going to do is like, I maybe try to simplify first. So 150, I can write it becomes square root 25 multiplied with 6. Then I get 150. So square root 25 is a 5, right? So I will be having 8 over 5 with a square root 6. Then again, I don't like to have any denominator at my with the third form, so I need to rationalize it. To rationalize it, I just multiply with sub 6 and also divided by square root 6 again. Then after I simplify, I will get 4 sub 6. So you're having 6 already divided by 8 become a 3. So you're having 15 here. Alright, so the answer should be 4 sub 6 over 15. This is the answer where I try to rationalize it until there's no third form in the denominator. Some students might want to keep the answer in this way, also can. Some students might want to keep the answer like this, also can. But to me, I think it will be better if you change it into this form. I think marking scheme, they did accept these two answers also, right? Okay, so this is what we have for part B. The cosine of the acute angle, the theta between the line L and also line M. Yeah. Then let's have a look for question number C, part C here. The point A lies on L has this coordinate. Point B lies on M has this coordinate. So they want to find the exact area of triangle APB. Okay, so maybe before we continue, right, we just try to rephrase again or recall again what kind of line do we have. We are having line L at the beginning. We are having line M. This is line M, let's say. I just simply do, I don't know how the line looks like. Okay, then just now we already know that there's an intersection point between these two lines, which is the P, right? Okay, and now they are saying that there's a point A on line L. So I simply plot a point A on line L. And also I simply plot a point B on line M. And they want us to find the exact area of triangle APB. So they want you to find this triangle area. Okay, so I believe that there's more than one way to solve it. So what am I thinking about now is I already have the theta here just now. Because just now they want us to find out the angle between the two lines, right? Which is this one. And it should be acute angle, so maybe the diagram that I draw is not correct. It might be somewhere here. Okay, but no matter how, it is just a brief illustration so that you roughly understand what the question wants. Okay, alright, so I'm having the theta here. And then to find out the triangle of area, right, you can actually use half AB sine C, sine theta. So you need to find out the length for the two sides, okay, that form the theta. Okay, so half AB sine C, sine theta, right? Okay, I need to find out the length for PA first. So find out the length for PA, I use addition in vector PO plus OA. So PO plus OA is this one, -2, -1, and then 3. Plus OA, OA is 0, 1, 1. And I get this vector, -2, 0, and also 4. And since I need the length of it, so I find out the modulus of it. So the modulus of PA is equals to square root of -2 plus 0 square plus 4 square. So the answer is square root 20. I just keep it in the exact form, right? I keep it in the exact form so that later when I want to do the calculation for area, it will be more accurate, the final answer. Okay, then I also want to find the length for PB. Okay, so find the vector for PB first, PO plus OB. So again, PO is the same value here, plus OB. So what's the value for OB? 2, 0, 2, and -8. And it is equals to -2, 1, and -5. And now I also want to find the length of the vector PB. Okay, so it will be square root -2 square plus 1 square plus 5 square. So when I total them out, it should be square root of 30. Okay, yeah, so I have the length for both sides here, PB and also AB. Then I can use it to calculate the area. So in the area, I need half AB sine C, right? I need to have the value of sine theta. How can I get the value for sine theta? Okay, so I have to recall back the value from part B. Cos theta is basically equals to 4 6 over 15. Or you are having 8 over 150, right? So I use back this result so that when I draw the triangle, it's not so complicated. Okay, so if I'm having cos theta equals to 8 over square root of 150, so what I want to do is like I want to draw a triangle for this angle here. So let's say this is a theta. So cos means adjacent. Adjacent will be the 8 over hypotenuse, which is square root 150. So what's the length for this side? So by using the Pythagoras theorem, you know that it is actually square root 150 square minus 8 square, then you square root the whole thing. So from here, by right, you should have square root 86. Okay? Then if you're having this triangle, right? then you should know what is the value for sine theta. So the sine theta is equals to square root 86 over square root 150. It is opposite over hypotenuse, right? So this is what we have. Okay, so after we get all the information here, let us compile everything together. So I want to get the area of triangle. Okay, so the area of triangle will be half the length of PA, the length of PB, and then sine theta. So substituting all the value here and we try to simplify them. Sub 20, sub 30, sine theta is square root 86 divided by square root 150. Okay, so since our number on the our number here, everything got surd form. So I can settle everything by using the surd form. One big surd, 20 multiply with 30 multiply with 86 divided by 150. So let's have a look what do we get from here. Okay, so by right, we should get square root 344 divided by 2. Okay, then after that, if you want, you can further simplify it. So try to simplify the square root 3 over, square root 344. Or if not, you can press calculator directly to help you and get the value. Alright, so square root 344 can be simplified as 86 square root times 2 outside. Which means that if you are using MS calculator, right, you should try and see. Actually, it can be written as 4 multiplied with 86 divided by 2. Then square root 4 is a 2, right? So 2 square root 86 divided by 2. Then of course your final answer is this one, which is square root 86. Yeah, so this is what we have lah. And then we have to keep it in this form, yeah, because in the question they said exact area, so you cannot put it into the long decimal number. So you have to just keep it in a surd form. So this is the area of the triangle. Alright, so this is the end of the part of the question 6. Question number 7. We are given parametric equations and they want us to prove that dy dx is having this. Okay, so for parametric equation, first of all, we have to start from the equation that they give us first. So x equals to 3 sine 2t. Then we found the differentiation for the equation here. dx over dt, it should be, differentiate the sign, you should get a cos. Copy the angle. Then you differentiate the angle. Differentiate 2t, you get a t. You get a 2, sorry. So you'll be having 6 cos 2t. Okay, then how about for the equation of y? So y equals to tangent t plus cotangent t. So there are many ways for you to differentiate this one. If I want to get dy dx, dy dt, there are many ways, yeah. Okay, so what am I going to do here is, I want to, before the differentiation, I plan to change tangent t. I can directly simplify it. I can directly differentiate, no problem, because I know the formula. But I didn't memorize the formula for cotangent t in differentiation. So I will change it become cos over sine first, where I want to use quotient rule for the cos x over sine x. Okay, so now let us start. I want to integrate the equation here. So I will get dy dt. Differentiate tangent, you have secant square. Then plus. So now let us differentiate this one by using the quotient rule. So just to recall a little bit about the quotient rule here. So what is the general formula? So quotient rule should be, when you are having u over v, the general formula is you square the denominator, copy the denominator, differentiate the top, then minus, now you copy the top, differentiate the denominator. Okay, so this is the general formula for the quotient rule. So let us start here and apply here. So square the bottom, so I'm having sine square x, copy the bottom, differentiate the top, differentiate cos x, you have negative sine x. Then minus, I copy the top now, differentiate the bottom, Differentiate the bottom, the original bottom is sine x, so differentiate sine, you get the cos. So you're having a cos x here. Okay? Alright, so to make you see it clearer, I move it first here. Okay, then after that, let us simplify it. 1 over sine, secant square is 1 over cos square. So 1 over cos square. I think I make some small mistake here, right? I shouldn't express my answer in x, but I should express my answer in terms of t. All this should be the t, cos t, sine t. Yeah, so sorry for that. Okay, so I'm having a t here, t, this one. Okay, so sine square t. Copy the bottom, differentiate the top. Minus, copy the top, differentiate the bottom. Differentiate sign, you get cos. Yeah, then after that, simplify further. Both sign here got negative, so I will want to change it become, take out the negative, I'm having sine square t plus cos square t divided by sine square t. Okay? Then from here, I know that cos square t plus sine square t should be equals to 1. So I'm having 1 over sine square t. So let's have a look here, yeah? Okay. And now, this is what I have for my dy dt. But I know that later, if I want to get dy dx in parametric equation, I need to use the chain rule. So the chain rule is dy over dt multiplied with dt over dx. Okay, so the dy over dt equals to dt over dx. So what should you do now is, for me, I think I will need to combine these two fractions into one so that later it's easier for me to multiply with some other things. Okay, of course you can combine it later if you want. So for me, I want to combine it directly here. So I'm having sine square t cos square t. Then I'm having sine square t minus cos square t. Yeah, so until this stage, then only I start the differentiation. How I start to combine these two equations together. So to get dy dx, I need to have dy over dt multiplied with dt over dx. So what's the dy dt here? I'm having sine square t minus cos square t divided by sine square cos square. dt dx, I'm having dx dt is this one. So dt dx will be 1 over 6 cos 2t. Okay, so now I still need to continue to rephrase it one more time. And let's see what can we do from here. Alright. What do I have here, yeah? So let's have a look for this one. Cos square and sine square. Can I change it become something related to cos 2t? Okay, so we recall again. If let's say you are aware just now, one of the double angle for cos involve both sine square and cos square. So cos 2t can be written as cos square minus sine square. This is one of the formula. And we are having sine square minus cos square, right? So I can actually take out the negative first, then it becomes cos square minus sine square, okay, divided by sine square cos square. Okay, so you can actually try to cancel cos square minus sine square with cos 2t. Because cos square sine square equals to cos 2t. So you simplify these two. Okay? Then next one. How can I simplify my equation further? So in my question, you are having something with sine square 2t. Can you see the double angle 2t? In my question here, I'm only having the single angle, which is t only. I want to change the t become 2t. Again, we have to think about the double angle formula. So double angle formula that involve both this sine and cos, right? I'm having this Sine 2t is equals to 2 sine t cos t. So if I try to make it become sine t cos t, then I will have half sine 2t. And now I want to replace this identity into my solution here. So on top, I'm still having -1. At the bottom, I'm still having a 6. Then for sine square, cos square, I want to make it become sine and cos, then square outside. So what is sine square, cos square? It is equals to half sine 2t. So I put in half sine 2t, then square outside. Okay, so after you expand, you'll be having 4 on top. Because 1 over 2, you need to square, right? So 1 over 2 square is 1 over 4. So 6 divided by 1 over 4, you get 3 over 2. 1 over 3 over 2, you get 2 over 3. So you're having -2 over 3. Then sine square 2t. And you can see this is basically what they want us to show in the equation on top. Alright? Yeah. So again, so like what I mentioned earlier, if let's say you can memorize some of the identity here, it actually will help a lot to give us some hint on how to lead to the final answer that they want us to show. Okay? Alright, so let's have a look for part B. For part B, we are having this. Okay, they want us to find the equation of normal to the curve at this point. So give your answer in this form, where PQR are integer. Alright, so to find out the equation of normal, I need two important things. The first one is I need the gradient of normal. After that, I need the coordinate x and y. What is the passing point? Alright, okay, so for this question, since we know that the t is equals to pi over 4, so first let us find out the x. What's the x coordinate that we get here? Okay, so the x coordinate is 3 sine 2t. So 2 multiplied with the t is pi over 4. T is pi over 4 here. So 2 multiplied with the t, you will be having pi over 2. So sine pi over 2 is a 1. Therefore, your x coordinate is a 3. Then now we try to figure out the y coordinate. So what is the formula for y coordinate? It is actually tangent theta, tangent t plus cotangent t. So tangent t plus cotangent t. And we'll get 2 from here. So I already have the passing point, the coordinate of x and y. This one done already. Then now we look for the gradient. So before we can get the gradient of normal, I need to get gradient of tangent first. So the gradient of tangent is actually from dy dx. So as my dy dx, -2 over 3. Then sine square 2t. So as a sine 2t again. So sine 2t will give you pi over 2. And you want to square it. Pi over 2 is a 1. 1 you square, you still get a 1. So from here, your gradient of tangent is -2 over 3. So again, you need to aware that the dy dx is the gradient of tangent. Okay, then now I want to get the gradient of normal. So how to get the gradient of normal? You know that when you're having a perpendicular line, a pair of perpendicular line, right? Their gradient multiplied together, we'll get the value -1. So to get the gradient of normal, it is equals to -1 divided by -2 over 3. Therefore, you should get +3 over 2. Okay, so I have the 3 important information already. I have the coordinate x and y, then I have the gradient of the normal. So I can form the equation of normal now. Okay, so for the equation of normal, it will be y minus y1 equals to m, then x minus x1. Okay, then simplify them. Okay, so simplify the pure number here, the number. So -9 over 2 plus 2. So by right, you should be having 2 is a 4, right? So we'll be having negative 5 over 2. But they ask us to put our answer in a certain form. So I get rid of the denominator by using by multiplying the 2 along the whole equation here. Okay, then after that I rephrase everything to the one to the left to the right. So I'm having this one. Alright, yeah. So basically this is how we actually get the answer for question number 7. Okay, so let's discuss question number 8. Okay, so we are given the function fx, which is a rational function, and then they are telling us that a is a positive constant. So express fx in partial fraction. Okay, so according to the question here, you can see that we are basically having the linear factor, yeah, okay, at the denominator where x is power 1, x is power 1. Then outside the bracket, it is also power 1. So we are having linear factor here. So to to separate the rational function into two partial fractions, so because they are linear factor, therefore you can directly expand them, become two partial fractions. The first one is a over a minus 2x. The other one will be b over 3a plus x. Alright, so we are having 7a squared equals to a 3a plus x, then b a minus 2x. Okay, so how I get from first step to the second step here? So basically I multiply the whole equation by using the original denominator. So when I multiply the whole equation, every single term with the original denominator, this is what I get after we simplify it. Okay, so now I want to get the value for a and also b. So to get the value of a or b, so we maybe can start from first bracket first. Let's have a look for this linear bracket, linear function. Linear factor. So 3a plus x. If I want to make this factor become 0, then I have to let x equals to negative 3a. So that substitute negative 3a inside this bracket, it becomes 0. So when it becomes 0, a also disappears. Then you can very easily get the value for b. Okay. Alright, so substitute x equals to negative 3a. So 7a squared is still 7a squared. So substitute negative 3a here, you get a 0 times a. Substitute negative 3a here, you'll be having 6a plus a, which is 7ab. And from this part, you should know that your b is basically equals to a. Okay, then next, let us find out the value of a, and now we are referring to maybe this particular bracket. How can I make this bracket become 0? So I will need to let x equals to half a. Okay, if I let x equals to half a, I substitute inside, this bracket becomes 0. So b disappear and we can find out the a from there. Alright, so again, left hand side, no x, so it is still 7a squared. Substitute half a here. Okay, then you'll be having 3 plus half. So 3 plus half will give you 7 over 2. A then a. Okay, then simplify this equation. So by right, you'll be having a equals to 2a. Yeah, alright, so we already get the partial fraction. Usually we will prefer to the students to rewrite it again if can, right? So try to rewrite again. So 7a squared divided by a minus 2x 3a plus x is equals to 2a, then divided by a minus 2x, a over 3a plus x. Okay, so this is how we basically get the partial fraction for this part, okay? Yeah. Right, so maybe you can continue to part B. Let's have a look for part B. For part B, they said hence obtain the expansion of fx in ascending power of x up to and including the term in x squared. So this question basically talking about the binomial expansion. So the formula is provided in the formula booklet. And I just show a few first few terms formula for the binomial expansion in this part. Okay, so I'm having 1 plus x power n. The first term is always a 1. The second term is always nx. The third term will be n minus 1 divided by 2 factorial, then x squared. And of course, you can expand it to x power 3, x power 4, and so on. Right? But for me, I don't think that we need it because we only need x squared in our expansion. So I think until this part is okay. Alright, so when you want to apply this particular formula, you have to make sure that the value of first term in the bracket must be always a 1. If it is not a 1, then basically you have to try to factorize the number out so that it becomes a 1 before you can apply this particular formula. Okay? And after that, the x in the terms here, the formula terms here, basically is the second term that you have. If let's say in your expansion you're having 2x in the bracket, then all the x here you have to substitute by using 2x. Okay? Right, so let's start. So they want us to expand fx, right? So what is the fx that we have? So fx that we have basically is, from first part, I'm having 2a, then a minus 2x power negative 1. For the second term, I'm having a, then bracket 3a plus x power negative 1. When you want to bring the denominator upwards, go up to as a numerator, then the power is negative 1, right? Okay. Then next. So next step is, you can see that this both bracket here, the first term are not 1. This is the a, this is the 3a. So first step, let us try to factorize the a out first. If I want to factorize the a come out from the bracket, so it need to follow with the power. Then I'm having 1 minus. To factorize out the a from the second term, you will need to have 2x over a power negative 1. Okay? Then plus, how about the second term here? Same thing happened. A I just copy. I need to factorize out 3a from the first term, right? So I'm having 3a power negative 1. After you factorize out the 3a, you will be having a 1. Then the x, factorize out the 3a, you should have x divided by 3a negative 1. Right, then what is next? So the next one will be, you take 2a divided by the a. A power negative 1 means divided by a, right? Okay, so for this particular bracket, I'm having 1 minus 2x over a, then power negative 1. Then for the second part here, you should have a divided by 3a, then 1 plus x over 3a power negative 1. Okay, so everything looks good right now, and we are going to apply the formula for the expansion for these two brackets. Okay, alright, so first, I'm having 2. So a and a can be cancelled off, right? So I'm having a number 2 in front here. Okay, then for this part, I want to write it by using the blue color. This one is a blue color. So to expand this particular bracket, first term is always a 1. Second term is an x. So you are taking negative 1 multiply with negative 2x over a. So the x is basically the whole second term, the second term in the bracket. Okay, then plus n and n minus 1. So you're having n is negative 1. N minus 1 means negative 1 minus 1, you get negative 2. Divided by 2 factorial with negative 2x over a power 2. So for me, the expansion, I will stop here because we just need to expand until x power 2 as requested by the question. So I just stop at the x power 2 here. Okay, then same thing happened for the next part. So I'm having plus, again, a and a can be simplified. So I'm having only 1 over 3. Then let's see what do we get when we want to expand this particular term. Okay, so first term is always a 1. Second term is n multiplied with x. So negative 1 multiplied with x over 3a. Then third term is n minus 1 become negative 2 divided by the new power. And after that, I'm having I'm having x over 3a. So x over 3a power 2. Then close bracket. Same thing happened here. I only want to expand the term until x squared, so that's why I stop here. If the question requested for x power 3, then of course you have to continue for more terms that include the x power 3. Okay, right. Then again, the next step is we just try to simplify all the expansion that we have. Okay, so if you didn't do any careless mistake by right, this is 1, then plus 2x over a, then plus 4x squared over a squared. Okay, then for the second term, if you didn't do any careless mistake by right, you should get 1, then minus x over 3a, okay, then plus x squared over 9a squared. Okay, then after that, I multiply in the 2 and also the 1 over 3 into the bracket. So I'm having 2 plus 4x over a plus 8x squared over a squared. Okay, then plus 1 over 3 minus x over 9a, then plus x squared over 27a squared. Okay, so now I want to group all the same term together where number add number together. So 2 plus 1 over 3, you get 7 over 3. For a over x, you are having 4 minus 1 over 9. So 4 minus 1 over 9 will give you 35 over 9. So 35x over 9a. How about the x squared and a squared term? So 8 plus 1 over 27. So 8 plus 1 over 27, you'll be having 217 over 27. Then x squared on top, a squared at the bottom. Okay, so after you simplify it by right, this is the answer that you should get. Okay, yeah, so this is what we have. Then let's have a look for part C. Part C, they ask us state the set of values for x when the expansion in part B is valid. Okay, so for the binomial expansion, right, we have two brackets that use the binomial expansion formula in the previous part. One of them is this one, 1 minus 2x over a power negative 1. Another one is 1 plus x over 3a power negative 1. Okay, so for these two bracket that we are using binomial expansion to expand it, right, there's a rule that we must follow. That means there's a certain value, set value of x so that the expansion is valid. Okay, so generally what is the how we decide the set of values for x? So basically the term at the back, so like for this one, the term at the back means negative 2x over a. The modulus of it should be less than the number in front. So the number in front for this particular bracket is a 1. Okay, then after that you should be having 2x over a smaller than 1. So if I want to keep modulus x here, because a and also the 2 are the numbers, right, and they are positive value, so when you move it over, you become x or a over 2. Okay, so if this one you want to expand, it should be from negative a over 2 until x, then to a over 2. Then how about for this bracket? Also the same thing. I'm having modulus x minus 3a smaller than 1. Okay, so I just want to keep the x here, so it will be smaller than 3a. Okay, so if you try to expand it, x is between 3a negative to 3a positive. Okay, but we are having these two set of value for x, right? But in our previous part, basically you can see that the expansion is all together one. I mean, the final answer, we combine the answer for these two expansion. So to make sure that the x is valid for both brackets here, we are choosing the set of value for x, which is the smaller set. So smaller set means that this is a smaller set, right? This is the larger set, right or not? So we'll choose the smaller one. And therefore the answer is negative a over 2 to positive a over 2. Okay, so we have to make sure that the set values of x are actually fulfill both expansion. Alright, the bracket of the expansion. Okay, so this is how we solve question number 8. Okay, so let's have a look for question number 9. Find the quotient and remainder when x power 4 plus 16 divided by x squared plus 4. Okay, so to find the quotient and remainder, there are two methods that you can do it. Either you apply a comparison method or you use long division. Okay, so if you are using the comparison method, that means in your equation, you should form the equation like this. The polynomial equals to division multiply with quotient plus remainder. Then after that, you compare left hand side and right hand side, then you try to solve and get the value. Okay, then another one is the long division. Okay, so you can apply the long division if you want, where you put the px here and then you put the divisor outside. Okay, right. So for me, I usually will apply long division. To me, I think it's more straightforward. Okay, so I start with x power 4. My polynomial is x power 4 plus 16. So usually for me, I'm worried that I will do some careless mistake, right? So usually for all the terms there's not a 6 in the polynomial, I will just put it as a coefficient 0. So I am having 0x cubed, 0x squared, 0x, then plus 16. Same thing happens for the divisor, but what I usually do is I write x squared. There's no term is in x, right? So I will just put it as 0x, then plus 4. Okay, so let's start for the quotient part. Something multiply with x squared to get x power 4. So what's the something here? So the something here should be x squared. X squared multiply with x squared, you get x power 4. X squared multiply with, after you multiply this one, you also have to multiply the second term. So x squared multiply with 0x, you will be having 0x cubed. Then the third one is x squared multiply with the 4. So I'm having positive 4x squared. Okay, then I draw a line. Okay, so according to the long division we learned last time, maybe in primary school, we are going to take the term on top minus the term at the bottom. So this minus this, you get 0. This minus this, you get also 0. 0x squared minus 4x squared, you have 4x squared, negative. Then bring down all the number on top. Then now you ask yourself again, something multiply with x squared to get negative 4x squared. So the something here should be negative 4. So negative 4 multiply with x squared, you get negative 4x squared. Okay, so just now I take negative 4 multiply with the first term, and now you have to take negative 4 multiply with the second term. So you'll be having 0x as well. Then the negative 4 multiply the third term, so you're having a negative 16. Okay, draw a line again. Take the number on top or term on top minus the term at the bottom. So you take 16 minus negative 16 and you get 32. Okay, so I think it's very, very obvious here where your quotient should be this one. And then this will be your remainder. Okay, alright, so you can rewrite your answer again. Quotient is basically x squared minus 4, and the remainder is basically 32. Right, so this is what we have for part A. Then let's continue to part B. Okay, part B. Hence, show that this integration will get this final answer. Okay, and you see the word hence, right? That means for this integration, you generally have to use the result in part A. Okay, so that you can continue with the correct integration technique or method. Right. Okay, so let's start here. I'm having 2 and then 2 sub 3 with x power 4 plus 16 divided by x squared plus 4. So just now, right, we can see actually in the previous part, they say that this is the polynomial and then this is the divisor. Okay, then I think I did show you one formula just now where it is actually polynomial equals to divisor multiply with quotient plus remainder. This is a general formula when we actually set up the polynomial here. Okay, then now if I divide every single term by using divisor, so the equation will become qx plus rx over dx. Okay, I divide every single term by using divisor. So divide divisor, divide divisor. So this is what we have now. And you can have a look here. This is what we exactly have here in the question, right? We are having px over divisor. So polynomial over divisor. So how can I rephrase my polynomial over divisor? So from the formula here, they did tell you that you have to use quotient plus remainder over divisor. So what's the quotient in our part A? So our quotient in part A is x squared minus 4. Then plus, what's the remainder in the first part? It is 32. Then divided by what? Divided by the divisor, which is x squared plus 4. Okay, so this is actually how they want us to link the previous answer with this part. Okay, so you always try to think back, what have I did, or what have I do in the previous part? So how can I apply it in this continuous part here? Alright, in the next part here. Right? Okay, then after I separate my expression, so let's have a look. X squared can be integrated easily. Negative 4 also can be integrated easily. When we are having 1 over x squared plus 4, how to integrate 1 over x squared plus 4? You can refer back to your integration formula. 1 over x squared plus 4 refer to this one. Okay, so this is the formula that you should refer to lah. 1 over x squared. When you integrate 1 over x squared plus a squared, you will be having 1 over a tangent inverse x over a. Okay, alright. So if you can remember this formula, that is even better, right? Okay, so let's put it here. If let's say I'm having 1 over x squared plus a squared, and I want to integrate it, the value that I get should be 1 over a, then tangent inverse x over a. Of course, there's a plus c at the back, okay? Right, then let's continue from here. Integrate x squared is a simple integration. So by right, you'll be having x power 3 divided by the new power. Integrate negative 4, you'll be having negative 4x. 32 is a constant, so you just try to copy it first. Okay, so I'm having 1 over x squared plus 2 squared. Yeah? So my a here is basically the 2. Okay, 4 is 2 squared, right? So a is a 2. So integrate 1 over x squared plus 2 squared, I will have 1 over 2. This is 1 over a lah. Then tangent inverse x over a, which is x over 2. Okay, then after that, I want to put in the limit 2 sub 3 and also the 2. Okay, so next step, we are trying to simplify all the terms that we have. Okay, x power 3. Substitute the x by using 2 sub 3. So 2 sub 3 power 3. What do I get? I'm having 8. 2 power 3 means 8. So sub 3 cube means that I'm having 3 sub 3. Then if I simplify it, I'll be having 8 sub 3. So the first term is 8 sub 3. Okay, then after that, substitute 2 sub 3 into negative 4x. So you should have negative 8 sub 3. Then this one, 32 over 2 is 16. Okay, then tangent inverse 2 sub 3 over 2. So I'm having sub 3. Okay, then now I want to substitute the value 2. Substitute 2, you'll be having 8 over 3 minus 8 plus 16 tangent inverse 1. Okay, then after that, let us try to simplify our answer. Okay, so 8 sub 3 and also negative 8 sub 3 can be cancelled off. Then what do I have here? 1 over 6 tangent inverse sub 3. So tangent inverse sub 3 is 60 degrees. So 60 degrees should be pi over 3. Okay, then minus, when I simplify all this, what do I have here is 16 over 3. So 16 over 3 negative 16 over 3. After I simplify all the terms here, I will be having positive 16 over 3. Then negative, if I put it inside, I will be having negative 16. Then tangent inverse 1 is pi over 4. Okay, then next one, let us try to simplify it. So I'm having 16 over 3 pi plus 16 over 3, then minus 4 pi. Okay, then when I try to add 16 over 3 pi to negative 4 pi. Okay, so what do I have here? So I will have 4 over 3 pi plus 16 over 3. then again, I have to refer to the answer that they want us to show, yeah. Okay, so they want us to prove that I will get this one. So very obvious, I think we have to factorize out the 4/3 and we'll get pi and then plus 4. So basically, this is how we get the answer that they want us to prove. Alright, so this is how we solve question number 9. Alright, so question number 10. There's a water tank in the shape of cuboid with the base area for 40,000. At the time t minutes, the depth of the water is h cm. Water is pumped into the tank at the rate of this one per minute. Okay, highlight the keyword rate and highlight the unit cm cube. So here they are talking about the rate of a volume, right? Of the volume of the cuboid or the water tank. Okay, so if let's say for this particular sentence here, I can write out some symbol which is dv over dt. So when you're seeing the rate, that means something over dt, and they're talking about the volume of the water, right? So it should be dv over dt equals to 50,000. So I just write 50,000, and this 50,000 should be a positive value, just that we didn't write it out, okay? Because the water pumps in, therefore it is a positive increasing, it is increasing volume, so we have positive value. Then after that, they said the water is leaking out of the tank through a hole at the bottom at the rate of 600 H per minute. So now, although we pump in the water, but at the same time, the water also leak out. So when the water leak out, the volume decreasing, right? So decreasing means that you have to minus, okay, 600 H per minute. Alright, okay, so first question, part A, show that 200 HT over DT, dH over dt equals to this one. Okay, if I have a look for the question, they're asking for dH over dt in the differential equation, but we have only dV over dt here. Okay, so what we need to do is that we have to use chain rule to connect dH dt and also dV dt. So maybe now we think about the volume formula for a cuboid first. So the volume formula for a cuboid is the base area multiplied with the height. Base area is given 40,000 multiplied with the height. So the height is the h. Yeah, so I can find out the dV dH from here, the differentiation. So you should be having 40,000. Okay. I'm having dV dt now. I'm having dV dH now. So I can use the chain rule to form dH dt. So what is dH dt here? So I should be using dH over dV multiplied with dV over dt. Okay, so dH over dt, dH over dV is 1 over 40,000 multiplied with dV over dt. This is what we have. So I'm having 50,000 minus 600 H. Then I think we can try to simplify our expression here. I can factorize out the 200. When I factorize out the 200, then I'm having 250 minus 3H divided by 40,000. Okay, then continue again. When I simplify the top and the bottom, so I'm having 200 here. So this is what we get, 250 minus 3H divided by 200. And hence, this is how we get the answer that they want us to show. If let's say I bring the 200 over, so I'm having 200 dH over dt equals to 250 minus 3H. Right, so this is what we have for the part A. Yeah, then let's continue to part B. Okay, so for part B, it is given that t equals to 0, h equals to 0. They want us to find the time taken for the depth of water tank to reach 80 cm. So this is h equals to 80. Give your answer correct to two significant figures. Okay, so to find the relationship between the h and t, right, we have to solve the differential equation first in the part A. Alright, So let's have a look for the differential equation in part A. We are basically having dH over dt with 200 equals to 250 minus 3h. Okay, so we have to separate the variable. I will want to bring 250 minus 3x, the whole thing, to 3h, the whole thing over here. Which means that I have to make it something like divide. So divide by 250 minus 3h. Keep the dh on the left, but I want to move the dt to the right hand side. Okay, then after that I will need to put the integration sign. So from here you can see that basically I successfully separate the h and d to two different sides. Okay, alright, so maybe some of you will want to ask why the 200 I want to keep it on the left. Since the question asked me to prove that the 200 and the equation is with the 200 on the left hand side, so I just keep it there. So I believe that if I differentiate like this, it's easier. Okay, sorry, if I integrate like this, it will be easier. So I just follow what the question give me, then I just follow and keep it on the left for the 200. Yeah. Alright, so let's integrate the equation now. So 200 is a constant I just copy. When you try to integrate when you try to integrate a bracket with a power 1 at the bottom, right? So you'll be having ln 250 minus 3h divided by the differentiation of the bracket, which is negative 3. Okay, then equals to integrate 1, you get a t, then plus c. Then next, since you are given the initial value, where t is equals to 0, h is equals to 50, so I want to substitute into the general equation that we get to get the value for the c. So if I substitute t equals to 0, h equals to 50, so I will be having negative 200 over 3 ln 150. And equals to 0 plus c. So I think it's very obvious that c equals to this particular value. Okay? Alright, so now if I write out my particular solution here, this is the c that I get. Okay, so it should be like this. Okay, then now, the question requested for the time taken when the height is 80. So to find the time t, I want to group all my terms on the other side first. So this one I bring it over to the left, become positive. Okay, then after that, if I factorize out the 200 over 3, right, I can rephrase my equation become something like this. 50 divided by 250 minus 3h. Okay, so from here to here, where is the rules that I'm using? I'm using the property of the ln, where I know that if let's say I'm having ln A minus ln B, I can group them become ln, single ln with A divided by B. Okay, so this is what I'm doing. Then next one, only I try to find out the value of t when h is equals to 80 cm. What happened to the t here? So if you're having ln 50 over 10, then just try to use the calculator to help you. So if you press the calculator, by right you should have a long number here. And after that, if I refer back to the question again, they're asking us to leave our answer correct to two significant figures. So two significant figure means the first two number here, which is 150, and then the 3 here, I will put it as 0. So it should be 150 minutes. Correct to two significant figure. Okay, so this is how we solve question number. Alright, so we are now at the last question for this paper. Okay, so the diagram shows the curve y equals to this one for 0 until 2 pi, minimum point at m, where x equals to a. Alright, so we are having a minimum point here. They want us to find the value of a to 2 decimal places. Alright, so we know that the a is a coordinate, x coordinate for the m, which is the minimum point, right? So at minimum point, we basically know that dy dx is equals to 0. Okay, alright, and then you have to take note also, where's the value for a? So the value of a is actually between pi until 2 pi, which is between 180 degree to 360 degree. Okay, so this is something that you need to know lah, because the diagram has provided us with a very useful information. Okay, so let us have a look for our first part. So y equals to 2 sine x with a bracket of 2 plus cos x power half. Okay, so this is basically product of two bracket or product of two function. When I want to do the differentiation for first bracket multiply with the second bracket, we have to use the product rule, where I copy the first bracket, differentiate the second, then I copy the second bracket, differentiate the first. Okay, so this is what we should do now, right? Okay, so we want to find the dy dx. Okay, copy the first bracket, differentiate the second. Differentiate the second means that you pull the power in front. Copy the bracket, power minus 1, so it becomes negative half. Then you differentiate the thing inside the bracket. Differentiate the thing inside the bracket, you will be having negative sine x, because differentiate cos, you have negative sine. Then plus, just now I copy the first bracket, differentiate the second. So now I want to copy the second bracket, differentiate the first. So differentiate 2 sine x, I will have 2 cos x, then multiply it for 1. Okay, so simplify all the terms here. I will be having sine x divided by square root of 2 plus cos x. Then I still have a negative sine x here. Okay, so negative sine x multiply with sine x, I'm having negative sine square x. Then the 2 and 2 can be simplified. So this is my first term here. Then for the second term, I will be having 2 cos x, then square root 2 plus cos x. Okay, then I know that m is the minimum point. Therefore, I have to let dy dx equals to 0. When I let it equals to 0, I want to solve this equation so that I can get the value for the x. So bring this term over, will become a plus. So I'm having sine square x divided by square root of 2 plus cos x equals to 2 cos x square root of 2 plus cos x. Okay, so to get rid of the denominator here, I bring it over and multiply. So it will become something like this, where I'm having sine square x, then 2 cos x square root multiply with square root, you'll get exactly what you have in the bracket. So I'm having 2 plus cos x. Okay, then next, how can I solve this equation? So let us expand it and have a look here. So I'm having 2 cos square, I'm having 4 cos x, then 2 cos square x. Okay, so when I'm having a mixture of the equation cos square and also sine square, it is quite hard for us to solve the equation. So we prefer to have everything in terms of cos or everything in terms of sine. So for me, I'm going to change the sine square, become 1 minus cos square. This is the identity that we learned in AS part, right? So I'm having 4 cos x plus 2 cos square x. Okay, then now I try to move everything to one side. So I'm having 3 cos square x plus 4 cos x, then minus 1 equals to 0. Okay, so now I'm having my whole equation in terms of cos x. So it's easy for us to solve it now, because you can observe from here that it is actually a quadratic equation, right? Yeah, so how you solve the quadratic equation? So you can either factorize it. If not, then you have to use the quadratic formula. So by looking at this, I know that it is something that cannot be factorized. So you directly use the formula. So I'm having negative b plus minus b squared minus 4ac. 4ac divided by 2a. So try to simplify. I'm having negative 4 plus minus 28 divided by 2, and if you know how to if you're using ES calculator, you can simplify this one directly by using the calculator. If not, then you have to do it slowly. 28 can be written as 7 times 4. Okay, so it can become 7 times 4, and the square root 4 is actually a 2, so you can write it as 2 sub 7. If you're using MS calculator, then maybe you have to simplify by yourself, yeah? Okay, then from here, you can see that I can simplify the denominator with the numerator, both by 2. Okay, so you'll be having negative 2 plus minus square root 7 divided by 3. So your cos x basically have two different values here. Okay, so cos x is equals to negative 2 plus square root 7 minus 3. Another one is cos x equals to negative 2 minus square root 7 over 3. Okay, so you try to press the calculator and get the inverse function, cos inverse. You will see that basically this equation will not give you any solution. Okay, because it is already less than negative 1. Okay, huh? Alright, so it is less than negative 1, therefore there's no solution from this part, we have to ignore it. Okay, then for this particular part here, I want to get the basic angle first for the equation. So the basic angle is cos inverse, the value here. Okay, so by right, you get the long value like 1.35384,056. If you want to make it easier, you can just directly correct it to 3 significant figure. But later when you do any calculation, right, so still keep it as a long value. Alright, when you write it out, you can write out short. Yeah, but when you want to show, when you want to press the value in the calculator, you have to keep it long. Okay, then after that, we want to find the value for the x, right? Okay, so we are looking for cos positive. So you have to ask yourself, in which quadrant cos will give you positive value? So again, this is everything, all sine, tangent, then cos. Okay, for the first quadrant, answer is basic angle. Second quadrant, answer is pi minus basic angle. Pi plus basic angle. 2 pi minus basic angle. Okay, so we are looking for cos positive. First quadrant, cos is positive. So I accept the answer from here, which is 1.35. Okay, then second quadrant, I don't accept the answer. Third quadrant, I don't accept the answer. Fourth quadrant, I accept the answer from here as well, which is 2 pi minus basic angle. So you'll get 4.93. Okay, so after you go through one quadrant, you are having two answers here. But which one refer to the x-coordinate of the m? So the x-coordinate of the m is actually the a. So the a is actually 4.93 only. Can anyone tell me why is it 4.93? Okay, so I think I did emphasize to you just now, right? The value of a is between pi until 2 pi. Therefore, the 4.93 is the value that is between pi until 2 pi. Then what happened to the 1.35? So the 1.35 basically refer to the x-coordinate of the maximum point, 1.35. Because at both maximum and minimum point, the dy dx is equal to 0, right? So it is common that it is correct that we find out the two value here. But for this particular value of a, it should be the value between pi to 2 pi. So the final answer is 4.93, correct to 2 decimal places. So this is the answer for 2 decimal places. Okay, all right. So let's continue to the very last part. Okay, so use the substitution of u plus 2 cos x. Find the exact area of the shaded region. Okay, then now let's have a look for our question first. To set up the equation for area, we need to know where the area start, where the area end first, right? Okay, so let's set up here first. To find the area, yeah, so basically you should know that we have to apply integration. So where is the area start? The area start at this point. It is actually x equals to 0. Area end at this point where it is x equals to pi. Okay, then after that, I'm having the equation 2 sine x sigma 2 plus cos x, then dx. Okay, so generally to find out the area, this is the formula that we should apply. Okay, so let's bring it to next part. Okay, so just now we already know that our area is this one, right? The general formula lah, okay? Right, so now for the differentiation of substitution, basically you have to start with the substitution equation first. They already give us the substitution equation, which is this one. So I'm having u equals to 2 plus cos x. So the general process is we have to find out the differentiation first. So I want to have du dx first. Okay, so differentiate a 2, you get a 0. Differentiate cos x, you have negative sine x. Okay, then I want to group all the x together. So I'm having negative sine x dx. Then maybe I want to bring the negative over, become negative du sine x dx. Okay, then after that, we haven't complete setting the question yet, set up the question yet. We need to also consider the limit. So you know that our limit is from 0 until pi, and all these are the value of the x. So let's start when x is equals to 0, right? When x is equals to 0, what happened to my value of u? So you should know that u is actually equals to 2 plus cos x. So what you do is like you put 2, then plus cos x means cos 0. Cos 0 will give you a value 1, so you get a 3 here. Then when x is equals to pi, so your u is basically equals to 2 plus cos pi. Cos pi will give you a value of negative 1, so 2 minus 1, you get 1. Okay, and you need to take note that when x is equals to 0, the value is larger. When x equals to pi, the value is smaller, right? Later, when you want to substitute the limit, please follow the original location. Okay? Alright, so after we set the question already, so let's continue to change all the variable x into the u before we start the integration. Okay, so let's start. Okay, we are having 0 until pi, right? So when x equals to 0, the value should be a 3. When x equals to pi, the value should be a 1. So I change become 3, 1. Okay, then after that, 2 is a 2 lah. Then you can have a look here. The sine x dx can be written as negative du, right? So I'm having a negative du at the back. Okay, then what happened to square root 2 plus cos x? So square root, you just keep it as square root. 2 plus cos x, you know, just now is a u. So I'm having 2 sub u negative du. Okay, then after I change everything from x become u already, then I can start the integration. So I take out the negative 2 as a constant first. I'm having 3, 1. Then I'm having u power half. Okay, so let's start the integration. For integration, power plus 1 become 3 over 2 divided by the new power 3 over 2. Then substitute the limit 1 and 3. So I prefer to take out all the constant one usually when I simplify everything. So I prefer to take out the constant. It will become negative 4 over 3. Substitute 1 into the u, I'm having 1. Substitute 3 into the u, I'm having square root 3 cube. I mean square root 3, then cube, right? So that means you're having 3 square root 3. Then the square root 3 and square root 3 can become a 3. So you're having 3 sub 3. So you can have 3 sub 3 here. And after that, simplify everything. So by right, you should have 4 sub 3 minus 4 over 3. So let's double check again. or they want us to find the exact area. So I think this is the exact area that we should keep. We should keep our answer in this form, where it is the exact area in the third form. Okay, yeah, so this is how we solve question number 11, and it is also the end of the video and this paper. So if you found that the video is useful for you, please help me to share the channel and subscribe it. Okay, so thank you very much. See you in the next video.